In this video, we're going to go over an FRQ question involving IVT, which is kind of that intermediate value theorem saying that if I have some f of a equals to some number, let's just call it 2, and f of b equals to some number, call it 6, then there must be an f of c that's equal to anything in between, let's just pick 3, 4, a is less than c is less than b. It's important that we kind of state all that. EVT is basically just telling us that we're going to have an absolute max and min on an interval, and specifically that those would occur at either a critical point or an endpoint. For both of these two functions, in order to apply them, f of x must be continuous. So that's kind of like our condition is f has to be continuous. That's the only thing it has to be. Then we also have MVT, I'm going to start with, which for MVT to apply, we had to have f being continuous and differentiable. If they just say differentiable, that's also okay. Because if they just say differentiable, f had to be continuous. So MVT kind of tells us that there's somewhere where we have an f prime of c equal to f of b minus f of a over b minus a, which is the instantaneous rate of change equals the average rate of change somewhere for a less than c less than b. And Rolle's theorem is very, very similar, but just adds the caveat of still f is differentiable, which also means it's continuous. But then now we also know that f of a equals f of b, and when we know that, the average rate of change part here, on the right, that part just becomes 0. So we get MVT, but where f prime of c equals to 0. So as we're doing these, we really want to be looking for what do I have, and is it the same that I'm doing IVT? Is it the derivative equal to a number? Then I'm doing MVT. Is it the derivative equal to 0? Then I'm doing Rolle's. Or do they ask about maximum and minimums? Then I'm doing EVT. So we have this table. It gives us two functions, f and g. It tells us that they're differentiable. As soon as I see that word, I know that I can use MVT, IVT, or Rolle's. It doesn't mean that we have to, right? There might be questions where we don't use them at all, and it told us it was differentiable. But, that's just, they now are in play. And then it also tells us g is strictly increasing. I'm not sure why I'm going to need that, but I'm going to underline that because it might come into play later. So the table gives values and their first derivatives at selected values. Is there guaranteed, part A, is there guaranteed to be a value c? As soon as I see this wording, that's like a huge, huge, huge hint to my brain that it's one of these theorems. As soon as I see that wording, I'm thinking IVT, MVT, or Rolle specifically. Usually that wording doesn't really apply to EVT. Technically, this could be an EVT problem as well, but usually it's one of those three. So where f of c equals to 8. So I have f of x, and I want to know, is there some f of c that's specifically IVT? Now, if I just look at the endpoints, this is what a lot of us get trapped into doing. If I just look at f of 1, which is 6, and f of 4, which is -1, well, no, 8 is not in between 6 and -1. So I'd say, no, doesn't have to be. But you always want to look at that sandwiching effect. So look, somewhere in between. Well, from 6 to 9, our graph would have to pass through 8 because it's differentiable, which means it's also continuous. So because it's continuous, to get from 6 to 9, we have to pass through 8. So we're going to sandwich this. And this is what I was talking about in class. This is what I need you to write down. Okay, you need to have written those down. Now, even a little bit better would be to write this, in a proper math sentence, which would be to say something like this. There is guaranteed. I like to just kind of repeat their wording. To be a value c for 1 less than c less than 4 such that f of c equals 8 because, now, this was just their wording. So all I did was repeat their wording. Now I want to make sure that I get into the IVT business. So I'm going to say because f of 1 is less than 8 is less than f of 2. Now it's not enough to just write that. I need to have also shown what the values were. I know they're in the table, but just rewrite them down here. Now, that's one part of the IVT explanation. The other part is to make sure we list our conditions. And f is continuous. Okay. So then, now I also need to say by what theorem I used. So then we're going to say by IVT. So by IVT, that happens. Now I can start off with by IVT. I can word this a lot of different ways. But the key that I like to kind of remember is I just copy down their wording, which was everything up until, this f of c equals 8. And then I say because, and then I'm going to, fill in what I need to on that theorem. So for an IVT theorem, I need to kind of fill in something like this, where I have one endpoint less than whatever I want, less than another endpoint. Now, they don't literally have to be the very ends. It could be the sandwiched endpoints. And then I also need to tell them that f is continuous, and I need to just write in IVT. Okay, next one, explain why there must be a value b for 1 less than b less than 4, such that g prime of b is 4/3. This one's actually a unique one that I can actually do IVT or MVT and get the right answer here. And so I'm going to kind of show that is when I say explain why there must be, again, I'm thinking immediately IVT rolls MVT. And when I see g prime of b equals 4/3, most of you guys are probably thinking MVT. And so we'll start there, but then I'm going to show you how we could have also done IVT. So if I'm thinking, MVT here because of the g prime, then what I want to kind of do is figure out, okay, what is g of 4? And g of 4 is 6. And what is g of 1? I go up on the table. G of 1 is 2. So then I'm going to just kind of write out, okay, well, g of 4 minus g of 1 over 4 minus 1. That's the average rate of change. That's 6 minus 2 over 3, which is 4/3. So that was my average rate of change, which they wanted. And MVT tells me that there is some time where g prime of c, or in this case b, that derivative, must equal this average rate of change. So I just showed, this is important. I need to show this work. I can't just say, oh yes, by MVT it works. I need to have actually shown that this was that average rate of change, right? I plugged it in. I'm showing that I plugged it in. So I'm going to say, there must be, you'd say yes, there must be if you want to, a value b, I'm just copying down their wording again, for 1 less than b less than 4, such that g prime of b equals to 4/3, because g is differentiable and then I kind of did already write this in, so you could just say by MVT, but if you want to say, you could say and g prime of c equals g of 4, actually this should be b, g prime of b equals g of 4 minus g of 1 over 4 minus 1 equals to 4/3 by MVT. So this is kind of the rule of MVT, right? G prime of c equals g of b minus g of a over b minus a, and we're showing that that was 4/3, and then we're going to say by MVT. So that's awesome for MVT, and we could have done that way. However, I wanted to show us kind of an alternate thing with this one that's something that we'll use from time to time. And that is that we can actually do this one with IVT instead of MVT. And so even though it's G prime, if we come back up here, we do have G prime. So we have exactly what we're asked for. And whenever those match, we can actually always do IVT, just like we did in part A. And so if we look at it, again, from 5 to 7, 5 to 7 doesn't pass through 4/3. But if we sandwich it here, from 5 to 1, 4/3 is 1.3, right? 1.33 repeating. So 4/3 would have to pass through there. So we could actually do this as an IVT problem, the same exact explanation as part A, and write something like, there must be, same wording as they have, there must be a value B for 1 less than B less than 4, such that G prime of B equals to 4/3. Now, what do I need to write down? I need to write down kind of on the side, okay, G prime of 1 is 5, and G prime of 2 is 1. So 4/3 does pass through there. So I'm going to say because, so I'm going to just write 1 is less than 4/3. And actually, instead of 1, I like to write G prime of 2, but I could write 1. But G prime of 2 is less than 4/3, which is less than G prime of 1. Right, G prime of 2 was this guy. And then that's less than 4/3, which is less than G prime of 1, which was that guy. And G is continuous. And we're going to say by IVT. So we did all of this by IVT. It might actually be better to say there must exist a value B, or like to put this by IVT at the front. Like by IVT, there must be a value. That way they're not thinking that you're saying G is continuous by IVT. They're not going to take off points, but just kind of like the English language. They might think that you're saying G is continuous by IVT and not this entire thing by IVT. Just like a small thing. So I might do that. Just place these guys in the front. C, is there guaranteed to be a value W for, they're just changing the variables, not a big deal, for 1 less than W less than 4, such that G double prime. Now, this one, G double prime, we do not have on our table. So like I said, G prime, we could have done MVT using G, right? Like G prime is the derivative of G. So we could have done MVT, which I showed down here. But we also could have done rolls. I showed up here because we want to figure out a G prime and we have a G prime. We do not have a G double prime. So the only option here, right, to go from G prime to G double prime, that's a derivative. The only option is either rolls or MVT. And because it's a number, it's 2/3, then we're focused in on MVT. So that's just kind of like a side note. So same thing that we did in B is I want to figure out, hey, what's G prime of 4 and what's G prime of 1? Why G prime and not G double prime? Because when I'm doing MVT, it's the average rate of change. So this is basically saying for MVT, it's saying that G double prime of some value W must equal to G prime of 4 minus G prime of 1 over 4 minus 1. It's kind of like, the average rate of change, the original MVT is F prime of C equals F of B minus F of A over B minus A. That's what we're used to. But in this case, because we have a double prime, we're just adding on a derivative to each part of this. So this will become G double prime instead of F prime. And these two values will become prime values instead of F values. So a little bit trickier because it's basically just down one level, right? We're doing the second derivative instead of the first derivative. So G prime of 4 in our table is 7, and G prime of 1 is 5. So this is going to equal to 7 minus 5 over 3, which is 2/3. That is what I wanted. I need to show that. So then I can say something like, I'm going to start off with the by MVT this time. By MVT, there is, and then just copy their wording, guaranteed a value W for 1 less than W less than 4, such that G double prime of W equals to 4, because G, now this one is a little bit tricky, but and in this one, actually, they probably should have told me G prime is differentiable. If they don't tell me G prime is differentiable, then actually, I could actually say, no, there's not guaranteed. And that's actually kind of a neat point I didn't think about before when I was writing this question, is in order for G double prime to work, we're working off of G prime. We're working like one layer down. So we would need G prime to be differentiable. If they didn't say that, we could actually say, no, MVT doesn't apply because we don't know if G prime is differentiable. But I'm going to pretend that I just added that in, G prime is differentiable. So because G prime is differentiable, again, why are we doing G prime instead of G? Is because they asked about G double prime. Okay. And then we could say something like G double prime of W equals, I'm just kind of copying this. You don't necessarily need to copy it because you already have the work, but I'm just copying it just to show it. All right, what is the minimum value? So this one's a little bit different. As soon as I see minimum, then a lot of times I think G prime equals to 0, make a number line. But as soon as I see over an interval from 1 to 4, now actually I'm still thinking that, but I'm mostly thinking, okay, wait, this is actually kind of an EVT problem where I'm going to have to do an absolute min or max. And usually on these I have to make a table, right, with my x's, and in this case I want the minimum of G, so G of x, and that's what I'm thinking. Okay, so I want to figure out first, where does G double prime equal 0? A lot of times writing just that line gives 1 point. Now, when I look back, I don't see any zeros on G prime. So let's go back and kind of read through these hints. Differentiable, and G is strictly increasing. I said we might need that later. This is where we're going to need it. If G is strictly increasing, that means the derivative is always positive. The derivative is always positive, so it never is 0. So G prime of x equals 0 actually gives no solution, right? Because G is increasing or strictly increasing. So that means there's no critical point. Now, what did EVT tell me? EVT told me that the maximums or minimums had critical points or endpoints. So if I make a table to help me out, my endpoints here are 1 and 4, and I don't have any critical points. So at 1, G is 2, and at 4, G is 6. So we'd say the minimum value of G is 2 at x equals 1. And you don't really need to say by EVT on this one because you showed it with the table. This is the one theorem where you don't really need to state the theorem. Now, if you really, really wanted to on this one because it was a little different with the no solution, you'd kind of say something like by EVT, the absolute min must occur at a critical point or an endpoint because G is strictly increasing there are no endpoints sorry, no critical points, there are endpoints. And the min must occur at, say, g of 1 equals 2. So you could write something like this, and it wouldn't be wrong, like you would get this correct. But the nice thing about EVT problems is EVT problems, you are basically allowed to justify it without having to write a sentence like that, as long as you have three things. The first thing is you show the critical points, which in this case, we had none of them. The second thing is that you show the table analyzing the critical points and the endpoints. And then the third thing is you just state the minimum or the maximum. And this last one, must there be, again, must there be a value k such that f double prime is 0. Again, we have this double prime, we're moving 1 over, where f double prime is 0. And so when I see a derivative equal to 0, that's a big thinking of rolls. Okay, and so we're kind of doing this over by 1. So normally roll says f prime of c equals to 0, but we're going to change it to f double prime of c equals to 0. So normally we have some f of a equals to some f of b that we're looking for, but because we're shifting 1 over, we're going to be looking for some f prime of a must equal to some f prime of b. Okay, that's what we're going to be looking for. So I'm going to be specifically, in this entire table, I'm going to be specifically looking in the f prime column. So if I just look at the endpoints 4 and 2, they're not the same. But can we sandwich this? Yes, we can. 2 and 2, those are the same. So I'm going to write in f of 2 equals, f prime of 2 equals 2, and f prime of 4 equals 2. That's what I want to make sure to write down. And then I would say, by rolls, there must be, just copy their wording, a value k for 1 less than k less than 4, such that f double prime of k equals 0, right? Because, and then I want to state out my reasonings for rolls. So because f is continuous and differentiable, and f prime of 2 equals to f prime of 4. So I basically stated, and I could put equals to 2 if I want, show that I know what number it is. So I basically stated, restated or rewrote there must be, and I said the conditions, continuous and differentiable, and I have an f of a equal to an f of b. Now, on this one, I might say something like, and g is continuous. Again, I said that we didn't actually have to write this one. But I did realize on my C and B, I just said continuous. I probably should say, differentiable. Probably should add continuous and differentiable there. And up here, continuous and differentiable would probably be a little better to say. All right, so this is kind of the exact same question, but with a little bit of a harder step to it. And this was actually from the 2007 FRQ. And so they gave us this h of x. And we actually cannot, the nice thing about it is we can't solve these problems unless we write out our values. So it says, explain why there must be a value r for, I messed this up, this should have been 1 less than r less than 3, such that h of r equals -5. Now when I see h of r, and I'm given an h, we're thinking that's IVT, right? When I see explain why there must be, I'm thinking one of the theorems, then I get h of r specifically, I have an h of x equation. That's almost always IVT. So how am I going to figure out if IVT even works? Because h is not in the table, right? I don't have h of x in the table. It's not there. So what I need to do is just plug in my endpoints. So plug in h of 1. And that gives me f of g of 1 minus 6 That's f of, now g of 1 is on the table. G of 1 is 2. So f of 2 minus 6. F of 2 is also on the table. F of 2 is 9. So I get 3. H of 1 is 3. Then I'm going to do the same thing for h of 3. So h of 3 is f of g of 3 minus 6. So this is composition. First I do g of 3. G of 3 is 4. So that becomes f of 4 minus 6. F of 4 is negative 1. And that gives me negative 7. So now my question is negative 5 in between those two values? Yes, it is. And that's what I need to kind of show, or show that work. I can't just say, oh yes, it's IVT. Right? If I just said IVT, I don't get any points. I first need to write out those two h of 1s and h of 3s and kind of show what they are. So now that I have those, now I need to say by IVT. So something like by IVT, there must be, just copy their wording, a value r such that 1 is less than r is less than 3. And h of r equals negative 5. I kind of messed up that wording, but it's okay. Okay. And then maybe like a comma, because now I do want to state that h is continuous. So because h is continuous, and then I'm going to say something like h of 3, that's the smallest one, is less than negative 5, which is less than h of 1. For the order, you always want to put the smaller one on the left. Not 3. 3 is bigger than 1, but smaller in terms of the answer, negative 7. And then the bigger one on the right. Right? H of 1 gave 3. 3 is the bigger number. All right. Explain why, this is the last question. Explain why there must be a value c. Again, I messed this up in their 2007. It was from 1 to 3. Explain why there must be a value c for 1 less than c less than 3, such that h prime of c is negative 5. Now this time, we want h prime. H prime is not up on the table. And I don't have an h prime graph. I have an h prime equation. I have an h equation. So this is a derivative. So when I see derivative, I'm thinking either rolls or MVT. Now, if it was equal to 0, I'd be thinking rolls. It's equal to a number, so I'm thinking immediately MVT there. So in order to do MVT, right, we need to kind of say that h prime of c is going to have to be equal to some h of b minus h of a over b minus a. Now, we already figured these out in part A. H of 3 was negative 7 minus h of 1 was 3 over 2. It's going to be negative 10 over 2, which is negative 5. So that is the condition for MVT. So then I can say by MVT, there must be a value c for 1 less than c less than 3, such that h prime of c equals to negative 5, because, now for MVT I want to say because h is continuous and differentiable, and h prime of c equals h of 3 minus h of 1 over 3 minus 1, which equals to negative 5. I'm just kind of re-copying down what I wrote up there. So to recap, when I get an IVT question, okay, what I need to write down is I need to rewrite their wording, and then I need to say that it was continuous, f was continuous, and then I need to write this kind of less than thing. The smaller number, less than what I want, less than the bigger number. And somewhere off on the side, I define those two endpoints. If I'm doing something with MVT, right? Anything with MVT, I need to write out this average rate of change formula and equal it to whatever I get, which should match up with what they wanted. And then I would say by MVT, there's guaranteed. And then my because, I need to say because G is continuous and differentiable. And then I just kind of rewrite this part. I don't need to show the steps in between, but to the final answer at least. For any minimum or maximums, it's actually just three things. I don't need to write a sentence. It's show that the derivative is 0, make a table, and then state the answer. And for anything with rolls, I need to show 2 spots where I have the same answer, right? So here it was 2 and 2. And I would say by rolls, there must be a value such that, and then my because is f is continuous and differentiable, and then I need to show those 2 numbers being equal to each other. So hopefully that helps with your writing out these justifications. I know this is a little bit of a longer video, but that should really help you to make sure that you're writing these the right way and getting the right answers.